Can we ever travel beyond the Milky Way? It's a question that pushes the limits of human imagination. We've barely scratched the surface of our own solar system. The farthest a human has ever traveled is the Moon. Yet the Milky Way galaxy spans about 100,000 light-years across and contains an estimated 100 billion stars. Even the nearest galaxy, Andromeda, is over 2 million light-years away. Can we ever hope to travel that far? This is the problem. Our current technology is nowhere close to intergalactic travel. Right now, the fastest spacecraft ever built is the Parker Solar Probe, which can reach speeds of about 430,000 miles per hour. That sounds impressive, but at that speed, it would still take more than 4,000 years just to reach the nearest star outside our solar system, Proxima Centauri, which is only 4.2 light-years away. Traveling outside the Milky Way, that's on a whole different scale. And this is where the agitation begins. When we think about traveling beyond the galaxy, we are dealing with distances so large that they challenge our sense of reality. Light itself takes 100,000 years to cross the Milky Way from one end to the other. Andromeda, our neighboring galaxy, is 2.5 million light-years away. Even if we could travel at the speed of light, which is currently impossible according to our understanding of physics, it would take us millions of years just to reach the closest galaxy. The problem isn't just distance, it's energy, time, and survival. Spacecraft need fuel, and the faster you want to go, the more fuel you need. But carrying that fuel adds weight, which in turn requires more fuel. This is called the rocket equation, and it makes traveling vast distances almost impossible using chemical rockets. There's also the problem of radiation. Beyond the protective bubble of Earth's magnetic field and atmosphere, space is full of high-energy particles that can damage DNA and electronics. A trip lasting millions of years would expose travelers to lethal levels of radiation unless they had significant shielding. Then there's the question of life support. How do you keep humans alive for millions of years? Even if we could build self-sustaining habitats, entire civilizations could rise and fall before a ship made it to another galaxy. These challenges make intergalactic travel seem like a fantasy. But is there a solution? This is where things get interesting. If we can't travel faster than light using rockets, maybe we need to rethink the way we travel. One idea is using generation ships. These are massive spacecraft designed to support entire communities of people over many generations. As the ship travels through space, generations would be born, live and die aboard the vessel, with their descendants continuing the journey. Generation ships could, in theory, allow us to cross interstellar or even intergalactic distances, but they come with challenges. Maintaining life support systems for thousands of years would require technology we don't yet have. There's also the psychological and cultural impact on people who would live their entire lives on a spaceship, never seeing a planet. Another idea is cryogenic sleep, or stasis. If we could safely put humans into a deep hibernation and wake them up decades, centuries, or even millennia later, we could eliminate the problem of long lifespans. Scientists are studying cryopreservation on a small scale today, but we are nowhere near being able to freeze and revive a living human without damage. But perhaps the most exciting possibility is to find a way to travel faster than light. One of the most popular concepts is the warp drive. This idea comes from Einstein's theory of general relativity, which shows that space-time itself can be stretched or compressed. If we could contract space in front of a spacecraft and expand it behind, we could effectively ride a wave of space-time and reach speeds faster than light without actually breaking the laws of physics. This concept, often called the Alcubierre drive after physicist Miguel Alcubierre, who proposed it in 1994, remains purely theoretical. It would require enormous amounts of energy, possibly more than the entire mass of the observable universe converted into energy, and exotic materials with negative energy density. So far, we have no way to create or manipulate such materials. Another possibility is the Schiller's wormholes, shortcuts through space-time that could connect distant points in the universe. Wormholes are predicted by the equations of general relativity, but like warp drives, they are purely hypothetical. Even if wormholes do exist, we have no idea how to find them, stabilize them, or use them for travel. And even if we did manage to travel faster than light, the sheer scale of the universe makes it unlikely we could leave the Milky Way and reach another galaxy in any practical time frame. But that doesn't mean we should give up. History shows us that technologies once thought impossible can become reality. 100 years ago, the idea of humans landing on the moon seemed like science fiction. Today, private companies are planning missions to Mars. There are steps we can take now to increase our chances of one day leaving the galaxy. First, we need to continue improving propulsion technology. Nuclear-powered rockets, solar sails, and ion drives could allow us to travel much faster than chemical rockets. NASA has already tested ion propulsion on missions like Deep Space One and Dawn. Solar sails, which use the pressure of sunlight to push spacecraft, have also been demonstrated by the Planetary Society's Light Sail project. Second, we need to develop self-sustaining life support systems. Closed-loop ecosystems, where all waste is recycled into food and oxygen, would be essential for long-duration missions. The International Space Station has already tested water recycling and other technologies, but we are far from being able to sustain human life indefinitely in space. Finally, we need to explore the universe using robotic probes while we develop human travel. Probes can travel for decades or centuries without the limitations of human lifespans. NASA's Voyager 1 and Voyager 2 spacecraft, launched in 1977, are still transmitting data from interstellar space more than 40 years later. Future probes could carry advanced artificial intelligence, making discoveries and preparing the way for humans. So can we ever travel beyond the Milky Way? With our current technology, the answer is no. The distances are simply too vast and the challenges too great. But the future is full of possibilities. If we continue to push the boundaries of physics and engineering, we may one day find a way to cross the unimaginable distances between galaxies. The question is not just whether we can travel beyond the Milky Way, it's whether we should. Leaving the galaxy would mean cutting ourselves off from the rest of humanity, possibly forever. It would be a journey into the absolute unknown with no guarantee of success. But exploration has always been a part of who we are. The Milky Way may be vast, but it may not always be our home. If humanity survives long enough, if we solve the challenges of energy, time, and survival, we could one day leave this galaxy and see others with our own eyes. And if we do, it will be the greatest journey of all time.